Hello, everyone. I wish you a very fun week. I'm Bruno Lopes. I work for Meta. This is Andy Kaylor, works for NVIDIA. And we're basically going to talk about how ClangIR came from an incubator state up to becoming Upstream, which is what we've been working on right now. So a quick recap. So when you look at the compiler pipeline in Clang, and you want to do like analysis and optimizations, you could either work on things in LLVM, which, because there's a big jump between AST and LLVM, it's like too low level sometimes to be able to kind of figure out more semantic, let's say from C or C++. And if you're trying to do things at the AST level, it might just be too high level. You don't have like a good way to reason on top of control flow and things like that. Even though you can make it work, a lot of the tasks are more well suited for an IR. So ClangIR kind of born out of this desire of dreaming more about things we can do with C++. Everyone knows C++ is really hard. It's hard to optimize. It's hard to analyze. So we feel like the more capabilities we have, and one of the ways to get there is having a richer IR, we can do more fun things in C++. And so far, we have been developing like some idiomatic analysis and optimizations, like trying to prototype some crazy ideas, like after a last use of an object, if you're copying from it, you might as well just turn that into a move. I know that can be aggressive, and you guys might want to throw me stones, but we might give us some gifts sometimes. So okay, so this is how the timeline of the project has looked so far. Around like late 2021, we started ClangIR at Meta, and we started it as an open source project under the Meta's open source GitHub thing. And after like 8 months, we submitted an RFC to on this course, asking for the community for feedback. Like, we want to do this, that's how we like look at C++ for the next decade, or that's how we want to kind of improve our things internally. And we know that this is a desire of the community. People have been talking about something like ClangIR for a long time. It's not something like we came up ourselves necessarily. So let's make this real. And to do that, you gotta like have feedback from the community, get expertise from a bunch of good people that are doing good work around. So that's how we started. Then we got finally moved to the incubator, which is what I'm gonna talk more about in a bit. After a couple of years, we finally sent an RFC for upstreaming the project into the LLVM project, which is the main repo. And then eventually the first PR landed. So, okay, let's focus on the incubator. So the whole idea with the incubator is a place where you can develop things, you can do a bunch of experiments. And as part of doing that, you gather feedback, you get other people that are interested in the project to also contribute to that project. And there is this kind of movement of knowledge and expertise going around in different parts of the project coming from different people. And as that thing matures, you slowly get your code into shape to kind of propose something like Upstream. So the idea is that we've been going in circles with like developing things, trying to design things, get feedback from people using those things. And as we go about them, we kind of improve the project, and we have more like higher quality code that can be used then for upstreaming. Also, it's a good place to see what works and what it doesn't work. I'm not going to claim, or in behalf of my colleagues as well, we're not going to claim that we know what the best design might be, because that might change with the workload you have, the priorities you have. But being this kind of process with other people, it's a very good learning experience as well. So in practice, like, what is the incubator, right? If you go to LLVM's GitHub, the main project, which everyone here uses, is under LLVM/LLVM project. The ClangIR incubator is within the GitHub LLVM, but it's in a separate directory. It's basically a fork of the project, and there are other incubated projects living alongside. So for example, Certi or like Polygeist, if you GitHub/LLVM, you're gonna see like directories for all of those things over there. So what kind of led to like us moving from RFC to incubator was basically the outcome of a discussion we had during the first RFC. And the outcome as part of that was basically, well, you should get together with the other experts in the industry. You guys should probably meet or do something about it. So we created this C and C++ MLIR front-end working group, which we've been meeting monthly for 3 years now, I think. It's an open meeting, so everyone is welcome to join, participate, give their opinion, ask questions. So we have that on the official LLVM documentation as well. You can find more information if you would like to join us. And eventually, after that, it was like, okay, get together with other members of the industry, experiment, do a bunch of things. And for that, you guys are now like ready to move the thing you have elsewhere into the LLVM umbrella of projects. So being incubated as a project has lots of advantages. Well, the main one, in my opinion, is visibility. Like, because you're part of the umbrella, your project gets more like, it's not a, how can I say, it's not necessarily makes anything better just because it's under the LLVM umbrella, but everyone knows, like, if you look at that, there's some level of sponsorship in a way, because, this is like under the umbrella of LLVM or something like that. So you get more visibility, there's a higher chance of people showing up and wanting to contribute. We can clearly see that difference, because when we were doing that on Meta's GitHub, it was a slightly different crowd than when we started doing that under the incubator. And as part of that, we get more contributions, more visibility, and also a lot of the support from LLVM GitHub itself, like the infrastructure, CI, we can easily like inherit from what the main project does, and it's easy for us to test projects at every commit, like run Clang format, all the good things that we can already do in the main repo. Of course, it's always a trade-off. So even though we have some visibility, it's not nearly as great as being part of the main project, right? We can see that as part of upstreaming, the traction that upstreaming is getting. You can clearly see the difference between being an incubated project versus being upstream. So, and also, if you are a company and you're like doing your own compiler thing downstream, you are way more likely to prefer forking from the LLVM project than from a fork of it, right? It's already really hard to live downstream and keep up to date with things. If you have to do that on top of someone else's fork, there's a lot of way more problems than you can find and things you have to catch up with. So we've been hearing this a lot over the years by talking with companies and other folks that, once you guys are upstream, then we might invest or we might like try to help. But just being a fork, it's still hard to kind of like get support from different parties. There's also a risk involved, right? Like management love that word, risk. Everything is risk. So being on a fork, it might end up that your project is never upstream, or it doesn't meet a bar or an imaginary bar, because that's also hard to kind of set. So there's also that perspective, right? If you're not mainline, like it's harder to convince some of your potential investors, let me put it like this. There's also an issue with like how the incubator process is supposed to work. We don't have a really like a well-established process. I'm not saying this as a necessarily complaint, but just it's nice to know that the expectation it's like you don't really know what to expect as part of like, when the incubation will end and we're gonna be like, we can be considered upstream, right? There's always a discussion after a discussion, but yeah, it's not formalized, so it can be challenging sometimes because over the years, a lot of things change, organization changes, maintainership might change. So there are some challenges involved with that part specifically. Well, one good aspect of incubation is like there's a certain level of freedom. This is one thing I think is great because, of course, you have, again, because of visibility, you might as well just have a reduced set of people reviewing code and participating in these discussions. So it's easier to, kind of go about landing work and experimenting with things with a little bit less scrutiny. And I don't mean that like we're not reviewing patches. I try my best to kind of use all the LLVM existing practices for every PR that we get in the project. But still, like we have a reduced number of reviewers, and that ends up reflecting in having a bit more freedom to do different things. And of course, by following existing LLVM practices, even just as part of the, even just being an incubator, but like following all the good LLVM practices, it's kind of a way to also like pave the long-term road to upstream your project. So there are a few challenges, of course. One of them I would say is, it's kind of confusing that now we have like both upstreaming and incubator. People like try one and blame the other for something not working. Like, oh, I tried this, it doesn't even build Hello World. I'm like, oh, you're trying a different project. And this was a couple months ago where like, beginning of the year where it wasn't, Hello World wasn't working upstream yet, but now that like Andy and NVIDIA did a bunch of goodness upstreaming, we are catching up very fast. And also, another thing is that we constantly go through rebases to try to keep things up to date against top of tree. And that's also a very challenging thing to do because it moves really fast. Everyone here that is a downstream client of LLVM knows the pain. So like we're constantly working on this and it's quite challenging to keep up, especially because MLIR will change under the hood. There's a bunch of things that change. So whenever we because we lower all the way down to LLVM, there are many moving pieces. And also, as we started moving things upstream, we got more visibility, so we got more reviewers, we got more scrutiny, and that means that also like upstream has started deviating from the way that things are done in the incubator, and this is for good, but it's also at the same time brings some challenges on like, well, let's backport this into the incubator, but some of the things in top of tree are already interacting with other pieces that the incubator isn't, so we end up having to do this whole kind of mechanism to rebase, but also don't conflict with what we have upstream. So it isn't the greatest place to be as things are getting upstream. The incubator becomes, a bit more challenging to handle in that aspect. So let's look at contributions a bit. We have like, I guess, a peak of burst of commits around like the beginning of 2022 when we were like kind of coming up with ClangIR and proposing the RFC. That was like a good initial time for landing work in this project. And then it kind of arrived for a bit until the beginning of 2024. That's where when we started getting like way more like consistent contributions. And then I guess the momentum now is like we have a really good pace of contributions this year as well, but not only in the incubator, but also on upstream, which we're going to show in a bit. Another interesting thing about like incubating a project is that authors, they come and go. It's, it's open source. Oh, compiler looks really nice. Let me try to land a patch, right? Like you do that once, and it's like, oh, it's not as cool as I thought it was. Let me go work on something else, right? So you never know. People might come and stay for a long time, 6 months, 2 weeks, couple days. It's a very interesting dynamics on how the community kind of evolves. So to that aspect, it's quite interesting because in ClangIR, we have a few pieces that are very mechanical because we look at classical codegen for doing a lot of things as inspiration because that path is known to work. So we kind of like try to stay close as possible if we don't have a need for like raising or doing something that it's more like the richer things we need. So one of the things are like built-ins or intrinsics. They're really good starters because you can implement some bizarre instruction from ARM and you do that in maybe 10, 15 lines, you add a test case, and then you landed your first compiler PR, and then you move on. So that's kind of interesting because by breaking things incrementally and kind of like asking people to do things incrementally as well as they go, even if they don't stick for longer, they at least did something that you don't have to revert and you can actually count on it to build something larger. So this has been like a great experience by like dealing with people over time. And actually being a bit annoying while reviewing because you know that you cannot count with like people maybe staying for longer. So you got to do your part of the work to make them break things down so it's useful for everyone. On the other hand, that's also like not great in some aspects because you want to build expertise, right? You want to have more people reviewing PRs. And if the people don't stick for longer, there's a tendency of like keeping doing that work yourself or to the reduced number of reviewers. So that's one of the things. So another reason that people might leave is that, like we're saying for upstreaming, it's risky for some people to rely on an incubator project. So some of our contributors over time, they just couldn't wait or they couldn't like spend more effort there at that point in time. So I was plotting this, what I call, I guess, scorpion-shaped graph to kind of see like what the contribution lifespan looked like for people around in the project. And as you can see, there's a solid base for some of the folks that have been contributing for longer. But there's like a lot of different like really small lifespans of contributions. And this graph doesn't consider people who only contributed once. For those, it's like around 23, but everything you can see on the graph in the left, it's basically 2 contributions or more. And as you can see, like as well in 2025, between 2024 and today, it's where like most of the contributions have been happening. And we're a total of like all time, like almost 90 people put up PRs so far in the past 3.5 years. So it's quite nice to see, and it really started catching up around the mid of like 2024, kind of doubled from there. So we also did like some, try to see where contributions are coming from and things like that. And another great thing about the incubation process is that other people got involved. There was a shift between the project being like dominated by meta contributions to actually being like wider contributions from the community. So for example, NVIDIA did a lot of work, like David Olsen initially, and then later Andy Kaylor and other folks showed up. And they've been doing like great stuff on the incubator as well. Most of the upstreaming plus backporting and helping us still getting like in a health kind of state, so that the incubator and upstream can keep being synced in a way that helps everyone. Here on the Google Summer of Code as well in red, if by the sake of this measurement, everyone, whoever, like all students we had on Google Summer of Code, they're forever Google Summer of Code student for the sake of this graph. So some of them just stick for longer, which is great, right? That's the idea. We want Google Summer of Code to be a place where you can learn and stick with the community. So we actually prove that that's kind of true. And also we have here in purple other, which is a mix between different companies that helped us along the way. Also like just the random open source people that show up and do good work. So that's kind of like a very interesting kind of direction and like proof that there's a big community aspect of doing something like this. So if we have to look back and think about well, was it worth doing an incubator project? I think there are many challenges. It's it's a community, so people think differently about different things, and you get lots of strong opinions, ways to do things. But I think in the end, all of this is actually very positive, because it's through over discussions and overheated arguments that we finally find common ground, and we can move ahead as a community. And I think that's kind of the gist I got from it. I met many people, I learned many different things, and I'm pretty sure most of the people also went through the same experience, especially with the C++ MLR front-end working group. Like, it's very nice to see the same people every month for like a couple years. You kind of build like more relationship, and then you can discuss things more freely. And I don't know, it was a very positive experience overall. And now, more specifically, that Upstreaming has a really good pace going on. I think that's a wonderful thing for the project and for the way we want to do C++ looking forward. So finally, we did the RFC for Upstream. That happened like early in 2024. At that point, we had support for a lot of companies and projects that want to be ClangIR users at some point, which was very valuable for putting the RFC up and kind of like getting the consensus, like backing up, having a list of stakeholders and things like that. We already had at that point like proof of concept of a lot of different things in C++ that we care about, like a lifetime checker that is aware of coroutines, for example, some idiom recognition analysis, and like also optimizations on top of it. And finally, we're able to lower it to a bunch of different targets. Well, at least 2 targets, but we can lower all the way down to LLVM and keep going in the compiler pipeline as if ClangIR was never there, right? So it's like very in the middle of the pipeline, and you can just use the rest as is.
All right, so now I'm going to talk about the upstreaming process, how we got things from the incubator to where they are today and where they will be, hopefully, in the near future. So as you see here in the timeline, April of 2024, the first PR for Upstreaming landed in the main repo, and had a bit of trouble getting some traction from there, but it's been going pretty well more recently. So I wanted to start about the upstreaming by talking about a useful accident that happened. I'm pretty sure nobody intended for it to be done this way. It wasn't planned, but it just happened that the group of people who are doing the upstreaming work and authoring the commits upstream are, for the most part, a different group of people than the people who did the original development in the incubator. Now, you might think that's terrible, it's a tragedy, but it turned out that that's been actually, I think, a blessing, an unexpected benefit to it. And it reminded me of the short story that I love by the Argentinian author Borges. It's called Pierre Menard, Author of the Quixote. And if you haven't heard of this story, it's about this guy in the 20th century who decides he wants to write Don Quixote. He doesn't want to copy it, doesn't want to translate it. He wants to write it from scratch, word for word, in the original 17th century Spanish. And that just strikes me as a perfect analogy for what we've been doing with the upstreaming. We have already this fairly mature code base of this is what we want, but we have to recreate it as if we were doing it for the first time. And so we have these new contributors who are coming in and taking this same code, but they're bringing a fresh perspective, and they're having to learn it, and they're having to go through the mental processes as if they were developing it. And it has brought something that I think unique to the development process. And one of the great benefits of this is that as you're doing this, you learn the code that you're upstreaming. You can't just copy and paste and you're done. You have to get deep into it and know what's going on with it. And so the result of this is that everything that's been upstreamed that wasn't written by the person who did the upstreaming, we now have twice as many people who have a deep understanding of that code as we would have had otherwise. And I think that's been fantastic. So now that we're going live with this, we've had it developed in the incubator. They made great progress, and is a, not complete work, but very, very functional and mature. And now we're trying to bring it into the main LLVM repo. And so, as I said, we're having to do everything as if we were doing it from scratch. Just when we first got approval to do the upstreaming, the Clang maintainers weren't on board with just bringing everything in and dumping it and saying, okay, we're going to merge. Here's 100,000 lines of code, because LLVM doesn't work that way. It's just not acceptable for the quality expectations, and it just couldn't happen. And because of the history of the incubator, the experimentation that had gone on, it had originally been developed in the MLIR subdirectory and then got migrated over to the Clang subdirectory. Some things, we explored paths that ended up being dead ends and had to go back and rework things. Because of all that history, you couldn't just replay the commits. And so there was no order saying, okay, give me the first commit, I'm going to upstream that, and no assembly line kind of thing. So you're having to take things, one piece at a time, where you just say, okay, I need to find a piece of functionality that is possible with what's upstream, and you need something that is complete enough to be tested, but at the same time, small enough to be effectively reviewed. And so this is the challenge that everyone who contributes to LLVM hopefully is familiar with. You have to meet these quality standards, and even though we have this mature code base, we're still having to meet the same standards that you would for any commit to LLVM. So, we need the contributor to thoroughly understand the code, to know, why decisions were made a certain way, to be able to defend it in the code review. All the functionality has to be tested by something in the pull request that's upstreaming, has to conform to the coding standards. We need it to be single purpose, keep the revision history clean. All these things that you do with a normal commit, we're doing with each commit. And so we've got this 100,000 lines of code that we're trying to get upstream, and we're having to do it one piece at a time like this. And that's the right way to do it, I think, and it's been very good for the quality of the code to do it that way. So Bruno showed earlier the contributors to the incubator. Here's a graph of who's been contributing to the upstreaming. And again, you see it's a good mix. So you see when the first commit happened back in April 2024, there's a long period of trying to figure out, okay, how does this process actually work? What are we doing? And other real life things that stall projects got in the way. But then toward the end of 2024, started getting a little more traction, getting organized. And then at the beginning of this year, in February of this year, we really started getting moving with this. And since February, we've been going at a really good stream. And so I wanted to mention one thing here with the Google Summer of Code contributors. You'll notice that the Google Summer of Code contribution is not limited to just summer. And it's also not entirely captured by the people who are identified here as Google Summer of Code commits. Because when we put out the announcement that we were looking for Google Summer of Code project, we had a number of great people who wanted to apply for this. And so they started actually contributing to the project before the decision was made as to who it was going to be. So we had already, we were getting benefits from just having said we're interested in Google Summer of Code. But beyond that, we were only able to accept one candidate. And most of these things in red are that one candidate. But we also had other people who applied, weren't accepted, and stuck around anyway and have still been contributing. And that's been just a fantastic to see that happening. So as far as our progress, I started this graph in February because that's where we really started getting traction. And you can see here, we're making very steady progress. It's actually surprised me how consistently it's been going up. It's about 1,500 lines of code per week going through the review process and getting into the main code base. And so we're chasing this line, and because of the scale of things, it's maybe not as clear, but the incubator is still growing too. So we're chasing it, and we're making good progress. And if you're wondering, okay, so where is this really now? I would say this isn't at the point that you're going to want to put it in a product or try to use it as your daily compiler. But if you're looking to build on top of it and you want to, say do some optimizations using CIR, I think now is probably a great time to get started. We've got enough language support in place that things work. And if you run into something that I'd like to work on this, but we're missing this language feature, if you let us know, we can do it on demand kind of. We've been working with the OpenACC development that way, and I think it's gone really well. So another thing about the progress, here's a few benchmarks that we've measured against using the LLVM test suite. The spec benchmarks, we're looking pretty low. We haven't, even in the incubator, nothing has been done to specifically try to enable these. These are just things that through the other work, this came live and is working. And because there are so few of these with so much code, and any missing language feature just drops the graph down really quickly. The single source test is something I actually am looking at and just running the test and say, okay, what didn't compile, what's blocking that, and then we're picking things off of that just as a way to organize the work of what to do next. And so you see, we've been making very quick progress with that. The multi-source, again, with the upstreaming work at least, we haven't been looking at that and trying to enable those yet, but that's something that as the single source tests get up to speed, we're going to start looking more at the multi-source just as a way to drive what language features we want to focus on. So one thing I want to say here, what we've been doing so far is, we're trying to follow the usual code path for, CPU compilation. We're mostly looking at Linux and x86 as the, default code path to get something working. And this is, so that we can test it and see where we are and have something that you can actually compile, execute, and run. But this isn't always going to be what happens with CIR. And so this is, even though we haven't started upstreaming this, I do want to emphasize that we have this box, consume MLIR here on this graph, that this is kind of intentionally vague in that it can be anything you want to do with MLIR, do some other optimizations. You might just optimize with MLIR and then lower it back to the LLVM IR and code gen that way. Or this might go to some offload target. This is where there's a lot of code pathfinding to be done, but I think this is one of the really exciting paths that CIR opens up. So a few growing pains. Bruno mentioned some of the problems in the incubator, and it's a lot of the same things have happened with the upstreaming. We've had, because currently when you build the LLVM project, ClangIR is off by default. You have to give it an option in your CMake line to enable this. And because that's off by default and we don't have build bots for it, we're not mature enough to put that burden on other developers yet. Because of that, we occasionally will get broken by somebody changes some interface in MLIR and didn't notice that we were using it, and so we have to update. But we're working on this every day and getting pretty quick turnaround on those fixes. So that's not really a huge problem. And then at the same time, the Clang is always in motion and always doing new things. And so we've had things where one of the trickiest things is there have been some changes in the Clang AST interfaces recently that because of the rebasing, the incubator is lagging a bit behind. So we'll go to upstream some code and it's calling some function that doesn't exist anymore. And we have to figure that out. So that's been going on. And as I said, we're kind of chasing two moving targets here as we're doing this. And it makes it a little more challenging, but it's just the way the process is. And so one of the challenges that we've specifically been looking at is trying to synchronize with the what we call the classic code gen. That's the name that we're using for the LLVM code gen path. So if you're a back-end developer, you might think code gen is when you're actually generating the target machine code. In the front end, in Clang, code gen is generating the IR. So that terminology, let me explain. But so we have one group of code that is what everybody uses today that is generating LLVM IR. And we're doing, essentially, we're modeling that with the ClangIR generation. We've tried to keep the structure the same so that if you're familiar with the LLVM IR code gen in Clang, then you're already going to be somewhat familiar with the way things are structured in the CIR generation. And so we're doing this. And another strategy that we've used, we're trying the goal is we want to generate code that is semantically equivalent to the LLVM IR. We want to align the same way they're aligning. We want to do everything that matches using generating the same attributes and code decorators. And it's difficult to do that without actual code sharing. And so one of the things we're doing is like we'll have when we generate a test, our tests test the CIR path of generating CIR and then lowering that to LLVM IR. But we're also adding checks for what the other code path without CIR does, so that we can compare that visually in the test, see what we're doing different and what we're still missing. But it also alerts us if something changes in the LLVM IR code gen, that will give us an alert that, hey, we need to update our code because they are doing something different now. And eventually, we hope to be able to run all of the existing Clang code gen tests with CIR enabled, but that's going to be a lot of work to get there. So I mentioned that we're trying to keep the same code structure. I said to somebody in a discussion recently that we're giving new meaning to the phrase embarrassingly parallel code. This is an example you can see. On the left, you have a snip of code from the Clang code, from the CIR code gen, and on the right, you have the equivalent code in the LLVM IR code gen. And you might actually have to look at this for a second to see what is actually different. The key difference and the reason that we can't just share the code is that the CIR is returning an MLIR value, whereas the LLVM IR code gen is returning a LLVM value. And so we can't just say, okay, we're going to use the same code here for both. But we want to eventually get to that point, and we're trying to figure out how to do that. So how do we do that? Right now we've got a lot of comments in the code saying this code is nearly identical. We should be able to share this, and over time we'll figure out places to move common code. But we're also trying to figure out, is there a way that we can do this with like templates or concepts to be able to abstract the IR substrate and get the code that can be shared to use this more abstract interface to those. And I actually put up a PR last Friday to kind of start this with the C++ ABI handling. It's very, very small baby step, but it's I guess the main thing I want to get across is we are thinking about this and trying to solve this problem, because we realize that just keeping these two nearly twin code paths is not a long-term sustainable thing to do. So finally, I wanted to talk about the process of getting help with this. Bruno mentioned this also, that we've gotten a lot of contributions from people who are new completely to the LLVM project, students who are just looking to get their feet wet in this and learn how it works. And this has been just a a fantastic process seeing all these great new contributors. Some people have come in and said, hey, I want to help. And it's very quickly apparent that they really aren't ready. But other people have come in, and I've just been really impressed with these people who still in college or maybe just completed their undergraduate work, and we've gotten really great contributions from people like that. And so it's been rewarding because the upstreaming work doesn't require you to have an in-depth prior knowledge of how the Clang front end works. It just requires discipline and a commitment to being willing to learn. And so I'd like to encourage anybody who's interested, please talk to us. We have a roundtable tomorrow at 2:15, and we'd love to help more people get involved. And so with that, I think we're wrapping up. I want to thank everyone who has helped contribute to the project, everyone who's made contributions to the incubator or the upstreaming. We couldn't have done it without help from everyone. Bruno, do you have any last things you wanted to say?
No, that's basically it. We're very grateful to have been able to build a community around this, and I think that's the greatest thing that happened as part of ClangIR.
All right, so with that, we've got just a few minutes for questions. Oh, yeah.
Have you guys thought about using some of the existing MLIR optimizations? Like I know Polygeist, you can raise SCF to affine, so maybe doing vectorization that way.
So no, we're not at that stage yet. Even the canonicalizer, which is something that might be more directly usable, it's too aggressive for us. So we wrote our own decomposed into using the pieces that compose the MLIR canonicalizer. But so far, we are not using yet any of those optimizations. The idea is to slowly grow into them, but we're kind of focused on correctness first. Once things are correct and work, then we can start enabling passes more aggressively. Yeah.
Thank you.
On your data flow chart, where you have some paths come out through LLVM and some paths maybe go to offloading. Are you anticipating that some of those offloading paths don't ultimately lead to going through LLVM-IR?
Yeah. So I think once you've gone into the consume MLIR, there is definitely a path to do some MLIR things from that and return eventually to LLVM-IR. I think most of the basic dialects can be lowered to the LLVM dialect, and so there is a path to get back. So that's depends on what the target is and how the target wants to generate its code.
But
is that your question?
I guess what I'm wondering is, why is that not just sort of conceptually in the CIR box, right? Why is that not just a loop in the CIR box and then ultimately?
Yeah, so I guess basically just the reason that I chose to highlight it as a separate thing is that once we've crossed that boundary, then it's up to the consumer to decide what they want to do with it, and it can come back to us and do more, but not necessarily, right? We don't know what they're going to do.
Okay, thank you.
I have a question about the upstreaming process. As someone who's also upstreaming a lot of downstream code, I feel like the major pain point is always find a fresh pair of eyes who's willing to look at your 100,000 lines of code. And I'm thinking being an incubator for years, you're probably also exhausting the people who are both interested in the project and a compiler expert, and you kind of turn into authors rather than a reviewer. Does anything in this incubator process will make this thing easier for you to do when you, in the end, trying to upstream everything?
I think I missed a bit on the what is the real question?
Oh, the real question is does being an incubator project will make finding reviewers in the end to upstream your code to be easier? Because I'm imagining as you're incubating, you're turning all those people who are interested in this area, turning into authors rather than people who can eventually review your code?
Okay, I got it. So I think it does. Of course, there's the problem that we mentioned about people coming and going, which is you cannot avoid. But we have now, I haven't been doing much upstream work myself, but I basically review all the PRs. And we have people who did contribute to the incubator who are now putting upstream stuff. Our previous Google Summer of Code students are also starting to review PRs. So same for Henry, who used to work for Trail of Bits and works for Next Silicon now. He's been involved with the project since the beginning. He's doing both. He review things on the incubator, review things upstreaming. Andy does that, I do that, a bunch of other people do. So yes, even though people might go away, there's a tendency of a few of them sticking around and actually working on both. So it's quite interesting. Some of the stuff I might have landed on the incubator myself a couple years ago. I can, someone is putting that PR for upstreaming and I'll say change this or that, because the role evolved, right? So
okay, thank you.
So in terms of performance, how and when CIR would have advantage over LLVM IR, and do you have any way to quantify that advantage? How much that would be, or any benchmark or any evidence to support that?
So far we only tried what we've been calling library-based peepholes, which is no substituting, let's say, calls to the C++ standard library for some calls to libc, and by certain key functions in micro benchmarks you get 3x's, right? But we haven't been able to build all of those big C++ projects where we can extract meaningful numbers. So if I tell you anything here, it'll be out of speculation. But because there are many ways you can go about optimizing things, even if it's just use ClangIR to do more analysis and emit more LLVM metadata, so the existing LLVM passes can work better, that's another route of getting more performance out, right? So we're very hopeful on all of those different strategies.
So you've mentioned a couple times keeping up with mainline is tricky. And as someone who is deeply involved with Sony's attempts to automate that, I sympathize a great deal. Do you have any automation for keeping up, or are you doing this periodically, manually? What?
I'm sorry, I didn't hear the question.
So you're needing to keep the ClangIR fork in sync with Upstream.
Uh-huh.
Do you automate this in any way?
So we, sorry if I didn't got it, but I think I got some of it. We plan, right now, we're trying to backport things. But I think that eventually either we're going to close the incubator or we're going to just, do a full initial rebase on top of ClangIR Upstream whenever it's considered that that's, we should just focus on that and forget the incubator. And maybe the incubator could just become a place where we can stage some of the optimization and analysis work that can later be upstream. I'm not really sure if I got your question right, but we can talk because I see Tanya's you guys are over time.
Yeah, I'll catch up with you later.